Hi everybody, so I was asked to think about an emergency pumping system that could be built from local materials in an emergency situation. And of course the heart of any pumping system is its valves, because the valves control fluid flow. They allow flow in only one direction, and quite possibly the simplest valve is a check valve. And check valve can be a whole load of things. It can be a flap of rubber, it can be a ball, it can be a spring with a plunger. A whole range of things can make a check valve. Now check valves operate because they only allow water flow in one direction. When the water flows in one direction, the pressure of the water opens the valve. When the water flow reverses, the pressure on the valve shuts it. Now, ball types are stunningly easy to construct, particularly if you have some of these. These are ping pong balls. I've chosen a ping pong ball because a ping pong ball fits really neatly in a standard fitting. This is a 40mm plastic fitting, or 3/4 of an inch. If we pop that ball in there, and this is actually a coupler, so it's meant for joining two pipes, then there's a little flange in there that the ball will sit against. So as the water comes up, it will open that. As it goes down, it will close it. Now, it would work just like that, but it'll work even better if we put a rubber O-ring. This again is a standard plumbered fitting meant for exactly this job, so surprise, surprise, that O-ring fits in there really rather neatly. Then we drop the ball in, and our valve is actually nearly made. What we need is a way of stopping the ball going all the way up. We need a block to it that still allows water flow, and of course we need to connect it to the pipe. So I've got a bit of pipe, a bit's going to go in there so it can be connected, and of course the next bit is going to go in there. That bit we don't shove all the way down, because if we shove it all the way down we'll trap the ball. You put it to a position where the ball can actually just lift, and that acts as a stop. Now it will lift against that pipe, and of course that is going to block it. So what we need to do is create a path, and we create a path by drilling some holes. Once you've drilled some holes and cut them out, you get this kind of castled effect. Now when the ball sits in there, of course, there's a path for the fluid to flow. The water can get around these holes that we've just created, but it still acts as a stop for the ball. So we're actually nearly done. We've got our O-ring in there, we pop it on there, we put our ball in there, and we pop that in there. And that pretty much is the valve done. The only thing we've got to do now is glue it together. And this stuff, of course, is solvent weld some plastic pipe, and it glues together with this stuff, solvent weld cement. Here in the UK we use Flowplast. In the US they use a different system, but it's still the same principle. And all we do with this is paint it on here, stick it in, make sure the ball can still move, and we're finished. So I've made two of them, and I've drawn an arrow on to show the direction, because when they're in series like that, then they will pump. We can give them a quick test just by blowing down it. If you blow, no problem. If you try this way, give it a go and you'll see what I mean. Or you could go, and you can feel it working. But there you go. That's how to make two very simple check valves. They probably cost, I don't know, 25p each or something. They were ridiculously cheap. Now we need to arrange them into an actual pump, but they are the heart of the system and the first thing you need to be able to build. Some stuff you need. The first thing is an old Venetian blind. I've obviously got this one still in its packet that I've had for about 12 years, and the slats are plastic, which is important. Then we need a bunch of tape. This is electrician's PVC tape. This is masking tape, and this is Gorilla tape. It's actually a gaffer tape. It's a waterproof plastic cloth tape, and this is actually key. So any tape will do as long as it's water resistant, as long as it's plastic coated, and as long as it's pretty strong. And this stuff, as I say, it's got a cloth weave, but gaffer tape fulfills all those requirements. I just use Gorilla Tape because it's here and it's pretty cool. So what we do is get this out the box and separate out those slats. So what we get is, in my case, 75 slats, and we knock those into line and bind them together with a bit of your electrician's tape. And bind them quite tightly into a nice block. There we go, and just go down there about 4 or 5 times. There you go, now we need to cut it off at 45 degrees, so stick it in the saw and saw it off. We've done that. Swap it round, choose some random number, I don't know, 16 centimetres, it really doesn't matter, 16 here, and so I'll use that, line it up, and then saw it the other way. So in no time at all, you'd end up with a whole load like that. Now they do have a slight problem. They are Venetian blinds, they've got a curl to them, and we want to take that curl out because it's PVC. Just stick it in some grease-proof paper and run an iron over it once, twice, and that'll take the curl out and you'll end up with a load like this. Now you need to decide how big it's going to be, and I'm going to put 20 of these aside. They're going to be square, so it's 4 sides. So I've got 80 of these ready, and now what we need to do is lay them out. Okay, I've got 20 of them all laid out and a bit of steel bar on top, and now a bit of masking tape onto the edges to hold them all in place. When our masking tape is down, we can take the bar away, and this is where this marvellous stuff comes in. What we'll do is take a strip of that and put that down the centre. And we've done that, both sides, we get this, and we can use that as a template to build the rest. So we put another bit of this on, but this time overlapping those edges. Flip it over, and we began with a long side here. So the next bit we put on is going to be that way up, going in there, and it'll be a short side. And you continue up. Okay, so we've done all of that. Now we put a last piece on, wrap it around a bit of 2x4, stick it down, because we're going to need to join up those edges. So we need to fix these edges to do that. So I'll stick that down, then I can curl this around, match them up, stick it down, tape it up. And when you've done that, that's what you'll get. Now it feels oddly like a tube of leatherette, and you'll see the zigzags that have been formed in each line, and we now need to fold that up. So we look for the zigzags because they'll be the square shape, and press both sides and it should start to form. And you can see it beginning to form there. So we go around that, pressing that, one in, one out. And that's what it looks like all folded up. It feels really nice and robust. The fillets that we put in there, they help the strength actually. This will handle a fair bit of pressure, but if you want more pressure, then you make those fillets thicker. So, you know, use oak or something like that, or maybe even metal. But that'll handle quite a bit of pressure anyway. Of course, what we want to do now is block off the ends. And to block off the ends, well, we just cut a bit of something. I mean, you know, plywood, MDF. I'm using this plastic board here. The plastic board will go in there and we'll tape all the way around it. And you'll see there's a hole in it. There's a hole in it to let the air in and out. On this side of one, it's a blank sheet that we fit a handle or something. But that just gets put in there, and then we tape around the edges using our Gorilla Tape, and that'll be a good enough seal. Okay, I put a nozzle on it. That's the basis, actually, of a surprising amount. They do use Bellows as water pumps, and this was used as a vacuum cleaner, and it shifts a surprising amount of air, actually. Oh, that's nice. So you could use it as a low energy air conditioning unit, because it's meant to shift air, and it shifts a huge volume relatively easily. But that's how to go about making Bellows. They're very, very useful for a whole host of things beyond just getting your fire lighted. Hope you enjoyed. We made this set of Bellows and these one-way valves. So Now we have our bellows and our one-way valves. What we're going to do is try and make a pump out of it. We're going to try and make a pump with the aid of this. It's a bit of Tupperware. It seals up, so you put that bit of Tupperware in there, close that handle and it's airtight. Brilliant. We need to get an exit and an entry into that, and to do that we're going to use these. These are tank fittings. They're plastic tank fittings made for screwing into the sides of toilets, that kind of thing. So we'll drill a hole, stick one there, stick one there, and that's where we're going to be putting these. Okay, so with a standard plumbing fitting, and these are called tank connectors, we've created an inlet and an outlet into our Tupperware box. And of course what we want to do now is connect this to the bellows, and to do that I've got a little bit of overflow pipe, which here is 22.5mm. That goes in there. Then I've got this reducer, and that will go in there. When we glue that in, the reducer will go in there, creating as a connection between the bellows and this box. Okay, now we've done that section, we can leave it to dry. There's actually quite an airflow coming out of there. And now we need to deal with the valve piece. So if we take the valves that we made in the previous video, we need to line them up so that they look like that. And to do that, we've got this plastic pipe fitting, which another solvent fitting just bought from the store, and they glue in together like that. We put a reducer from here that will go into that tank fitting. Okay, that's the valve unit all glued together. Notice the arrows are in the same direction. This goes in here, and then we can put a pipe in the bottom there to pump it and see if it actually works. So let's glue that in there and get some water. Okay, there it is set up. I've got it in a bucket of water, and we're going to see if it actually pumps. Now it might need to be primed. Remember, the valve is here, so the water will find its own level. So if the water level is here, of course this water level will try to drop to the valve. That's why you have this chamber. But let's give it a go and see. Jeez, I mean, it takes some lifting, because that's some... No! Wow! Oh, jeez! Okay, that's so cool. That was awesome. I mean, it's a bit of a job to pull that handle because we're raising quite a weight of water. So, you know, we'd need some kind of lever, I think. But as a proof of concept for the concertina pump, I mean, that works an absolute treat. Of course, separating the water from the concertina means this will never get wet, so you don't have to worry about that. And it's pumping quite a large volume of water, which is why I'm having to lift quite a weight. And Luke referred to it as a big straw. And he's basically correct. This is a straw, two valves to ensure one direction, and this replaces you sucking on the straw. So we have our concertina pump valve, and the idea here is that this was made from readily available plastic plumbing parts and gaffer tape, so you can make it in pretty much extreme conditions. So there are no precision parts here, the whole idea being that this can be made easily and cheaply by anybody without power tools, so an absolute piece of cake. Now if you stuck a filter on the end of that pipe there, the one going into the water, you'd be able to filter out debris, and of course that means you could chuck it in a river. Of course you'd still need to boil your water, but you could just pump any water source from it. It does need a lever because it was quite a weight to actually lift, and you'd soon get tired doing it. So this is a vane motor. It's actually incredibly simple. I've drawn this up on Tinkercad, and I've put the files available on Thingiverse for anybody who wants to give it a go making their own vane motor. And vane motors have a long history. They're pneumatic motors. They work by air or water. and they're being used because they're incredibly power dense. I mean, there's nothing to them. They're way next to nothing. They're far more power dense than an electric motor. They have their disadvantages, obviously. Everything has both advantages and disadvantages, but you'll find these used in things like power tools. You're also finding them being used in things like pneumatic cars, because air-driven cars are a competition against electric cars for a whole host of reasons, including they're cheaper, they're lighter, the compressed air doesn't store as much energy as a battery, but it weighs far less, and so on and so on. There's a ton of reasons people are interested in air motors. And because these weigh so little, there's a plan to stick these on the wheels. But let's have a look at how it's actually made. There are in fact only 4 sections. There's the central rotor section, there's this body housing and a cap, and then there are 4 little slotted things called vanes. The rotor goes in that there. That is a skater bearing 22mm by 8mm by 7mm. The rotor goes through there. I've put a bit of 8mm steel bar on the rotor and it sits like that. Now the vanes just slot in. You've got to pay particular attention to this bit. That bit there goes to the bottom, and on the corresponding vane it equally goes to the bottom. Then the little leg on the next set of vanes goes to the top, so one can slide over the other. So we put them together like that. And that is your vane motor made. The cap goes on so that that lines up with that. There we go. We're done. They have incredibly low inertia, so these things, depending on the design, will run at something like 25,000 RPM, which is just crazy. And they're easy to get going. So easy we can run this one from just a balloon. This one leaks like a sieve, eh? But still it works, which is pretty impressive for what these motors are. Now, of course, we want to do something with it. Now, I make a lot of these all the same way, so if you've been looking at previous videos, then you'll know about this. This is a serpentine coil, and I've included the former in the file, which is on Thingiverse, and I've wrapped 250 turns of 0.2mm copper wire onto that in a serpent, and of course I've made a disc that fits in there nicely, and that's 24 neodymium magnets, and they're 1cm by 2mm, and they fit in that disc, which is again in the file, and that slots in there, and that can rotate, and when that rotates, of course, it's a generator. So we're going to put that onto our vane motor, and to do that we've got a connection disc. The connection disc goes on like that. We glue that on there, we glue that onto there, and then we put that onto there, and that makes a generator out of the vane motor. The glue I'm going to use is this. It's cyanoacrylic glue, and I use a bit of activator to make it all work very quickly. So let's glue that together. Okay, and that's it together. Now, I have done quite a few videos on how to wind these serpentine coils, but I will put a link at the end of this video on how to make the serpentine coil. But there we go. There is our vane motor generator, and what we're going to do is blow into this and see if we can get anything out of it. Okay, that took me some puff, but we got 3 volts out of this thing, which is amazing. So I would say proof of concept, we've shown that we can actually do it. Of course, there are other things to do with it, like give it a steadier air supply, but certainly it works. So the next thing is going to be something with a steadier air supply. And guess what's sitting right here? Now, I've reduced the size of this so that we don't have the water pump bits that it had. And I've made a little adapter to go into there because that goes straight on there. And you might notice there's some arrows on it telling me which way the airflow is. So, of course, I need to put air in here. And on the bellows, it just goes straight on there. That is my generator made. So all I have to do now is pump those bellows and we'll be able to generate. So let's do that. Okay, so that was just so you could see it spinning, and of course these fell out without the cap on, so let's put them back in. Oh, I glued them together because I knew I was going to do that, and I thought, well, if they're all four are separate, it's going to come flying out. But we got a result out of that that you could see. We'll put them back in, put the cap on, we'll give it another go. I thought that was awesome. You could charge your phone on that really easily. Now, I made a couple of adaptations to this, incidentally, because I found that the airflow was occluded because of the generator plate. So I put 3 holes in the cap, and that cured that problem. And I also put a bearing in here to help things run a bit more smoothly and true, but that's all I've actually done to it. The thing to pay attention to is not the vane pump. The vane pump's only the generation part, and is in fact modular. So we have a way of creating our air supply, which is the bellows. Now, the bellows would work better if there were 2 of them and they were going up and down like that, so you would get a more even airflow, a bit like a Japanese box, but one works just fine. I have one, and that's what I used. The other section of the module is this, which is the valve section, because when we want it to draw air, we want the air drawn from the outside, not from the motor side, and so this draws the air from the outside and pushes it through to the motor, so that's an important section. Then of course the bellows, which is a energy gathering section. So those 3 bits go together quite well, but if you wanted to use something different to a vane pump, if you remember we made the blowtorch where we just used a rotor, the rotor would work quite well as well. The vane pump obviously works really quite well, but those parts are modular and they could be put together as a module depending on what you have available to you. And the whole point of this is this could be constructed from basically bits you've got lying around. And remember, we also did a modification to a motor from a drill where we could run that by putting something like a vane pump on top of the drill rather than the serpentine coil section that I've done. So it's a bit of a mix and match for what you want to do, but for me this solution works really quite well in that we've got the bellows as our energy and our air, we've got the air being directed, and then we're directing it over something that will change that into rotation, and then we're using that rotation for generation. Anyway, all of this stuff is on Thingiverse. If you want to jump over there and have a look at my page on Thingiverse, you'll see them all. I've put links in the videos. I hope you enjoyed this video. Thank you very much for watching, and please do remember to like and subscribe.